is the right answer typically. All right, folks, we are looking at Unit 10, and Unit 10 talks about Python libraries. And like most programming languages, Python is no exception. Much of the stuff that it can do natively with the commands that you type in a Python program are based upon the pre-built functions that are built into the Python standard libraries. And in other words, Python includes bundled with it libraries of pre-created functions of various sorts that in some cases you don't have to call, and in other cases you do have to call into your program with an import that will perform specific tasks once you know the correct syntax to have the tasks performed. You can take a look here as I scroll down in the unit folder here that we do have a link out to a LinkedIn Learning video course that talks about working with the Python standard libraries. Now, this is a complete course. I'm just going to bop over there really quick. I'm not going to play any of the videos, so don't worry about that. I just wanted you to kind of look at the topics here. And they do have exercise files, so if you want to follow along. And a lot of the stuff that they're going to show here, I'm assuming, right, that you guys can probably just skip over, right, because you've already been taught this. So things like logical operators, like and, or, and not, and comparison operators, and things like that. But then you get into some more specific commands that do pull upon the library. So like in this case, they're looking at calculating length, for example. And that's a very common calculation. And there happen to be library elements that would handle that. Now, a lot of people are like, well, I know how to calculate length, I measure it. But when you start to look at some of the things that are pre-built into the libraries that help you perform the function, that's what this is all about. So it's just a matter of, in some cases, feeding the right data in the right way to the function or the API, and then it'll bring back the data that you need. As you kind of push forward here, you notice they go into math, where they do some real basic things. And if you kind of compare this to the stuff that we were looking at in Excel, I think this is pretty fascinating, right? Because you can do a lot of the basic math functions through the libraries in Python. So here they're talking about trig functions, ceiling, floor, and constants, factorial, square roots, greatest common denominator, random numbers. Hey, this might be interesting, calculating statistics with Python. That kind of leads right into our next unit, by the way. So that's a really good read. And they talk about looping. That's what iterators are, by the way. And then they also look at input and outputs. In other words, getting stuff from the user, adding command line arguments to programs, for example, inputting and outputting files. That's something that Python does very elegantly, which is why it's one of the favorite tools for data people, by the way. And then also what I think is kind of interesting for any of you that are into the web thing, using Python to actually interact with web pages, in many cases live websites, where you can actually use Python to parse, or basically what we call read through a page, pull the data off the page, find the pertinent pieces of data from the page, and then analyze the data on top of it all. And I think that's really crazy powerful when you think about it. And they demonstrate all that in this video. So, and this is a complete course. So if you guys can spare the time to go through the whole thing, I think you'll have great benefit in going through it. I've watched some of it, clearly not on this computer, but next thing I want to go into here is I do have a link to the Python standard library on the python.org site. And what this really is, it's the equivalent, what in other languages we call the docs, or the documentation, or the manual pages for a product. And what the Python standard library is here is just a way for you to figure out how to do certain things that are really common inside this library. And I'm just kind of scrolling through here slowly to show you all the different types of things that are available in the standard libraries. These are not add-on libraries. but they're in the standard libraries. I will have you notice though, so let's say, for example, if I was looking to send emails through an application, you would have to import the email library, and a lot of these are named here. And as you kind of scroll down here, you'll notice that they have libraries for doing just about everything that you can think of. And it's pretty crazy powerful, because in many other applications, it's not quite a clear roadmap. Usually you have to download tools and install them. And the documentation is extensive, as you can see. Right. So if there's anything here you want to try to figure out how to do with the Python standard libraries, chances are you'll find that information here. And here it is for the taking, folks. And if you want to click into any particular thing, I'm trying to think of like something you may have learned, because we have not. Okay, so for example, we brought in that OS library. What the heck is that, right? So we brought it in and used it. And here is a complete formal description of what this does. Provides a portable way of using operating system dependent functionality if you just want to read or write a file. See, open, and then they then start to demonstrate all the different commands that you have available to you, how to use them, what the output is. And this is very common in a programming language. So somebody documents all the methods that are built into this library, and then you can look them up here and then figure out, what platform you're using. I'm noticing there's some of these that are only available in certain operating systems, but that makes sense for an operating system library that was written probably around Unix, that they have a lot of Unix specific stuff. But that's just the overview of what's available here. One thing that really feels overwhelming, and I'm sure you guys are feeling this, right? Whenever you're working with a language like this, and it's like, oh my God, that library list is extensive. I hope he doesn't test us on this, right? And that would never happen, by the way. If I asked you like a library question, it would be something really basic, like, which library allows us to do GUI, for example, and that would be tkinter. But if you're working in a language, there's no way to memorize everything. It's just, there isn't, folks. And the way that stuff changes so quickly doesn't help. And so what most coders do as kind of a rule of thumb is, if you're a heavy Python programmer, you might bookmark this page because you're checking it all the time. Also important to note, a lot of our better IDEs automatically connect to these document libraries and pull in descriptions for the tools you're using right inside the IDE directly from this library, by the way. And I think that's kind of a neat thing to think about as well. All right, so that's the Python standard library, which is the documentation for the Python language. The only other thing I'm going to point out here is that it is relative to a version. On this new machine that I'm using, I think that is the version that I have. I know it's a 3.9 version, so that should be pertinent to what I have on my machine. If you installed Python over the course of the last year, you may have version 3.6, 3.7, or 3.8, depending on when you installed. They do go through version numbers pretty quickly, and you can see they're kind of at the tail end of the 3 point whatever. So I'm thinking, are they coming out with version 4 soon, or are they going to just make these ridiculously long ones for 0.9? All right, that's an overview of that. The next thing that we have in here that I want you guys to read through, and this comes from an article, and once again from that website that we pointed out from the last unit. Really cool website, highly recommended, by the way. They have this interesting article talking about the top 10 libraries, Python libraries for data science. And the first one you're going to see right off the bat here is Pandas, and that's one of the first ones we're going to play with. And like many of the libraries out there, in fact, I think just about all of them are open source tools that are out there that everybody uses. And you can read up on what they do. So for example, it says here, Pandas can take data in CSV or TSV, tab separated instead of comma, or a SQL database and create a Python object with rows, columns in a data frame. So we can import from all of those formats natively. And we just saw how we can work with an Excel file even, right? and do some pretty intense things. But that's Pandas. It's not the tool that we were using. Another real popular library is Numpy, and this one is used um, real heavily when you're working with data sets that are kind of pre-organized into list or dictionary structures, typically, um, and allows us to kind of manipulate the data. So often what we'll do, just as an example, is you read in some data from a file or enter it, and then it gets put into like a list, an array, or a dictionary, and then you use NumPy to do things like sort it, A to Z, or biggest to smallest, that kind of thing. And that's a way that you can do some pretty interesting tasks. A couple of others that you see very, very commonly, SciPy and the matplot library. And number 4 there is one that we will use to create some visualizations on a basic level. Sometimes you have to combine that one with other libraries to have it work correctly. But interestingly, you can pull in data in tabular format, like a CSV file, Excel file, whatever, and then put those things typically into arrays and sometimes not, and then plot the data using a variety of different types of visualizations, bar charts, scatter plots, line graphs, etc. All of that is possible with this. So very, very commonly used. Here's some of the visualizations you can create with it. Very common ones, right? So these are all things that are available inside of Excel as well. Seabourn, now here's one that I have not used. I've seen it demonstrated a couple of times. And this one is used for doing higher end graphics and doing some pretty kind of neat things, including showing the example that I saw was they were doing a regression analysis on COVID data, and they were allowing it to kind of interface between the different types of information being fed to it and dynamically have the thing adjust while you're changing the data. It was kind of cool. And we have the Scikit-Learn, another real popular one. And you can see some of the things that that's used for. It's a little bit higher level one. Tensorflow is one that is also pretty heavily used. And I want you to notice that some of the things that this does, because this is kind of related to machine learning and artificial intelligence. But it says here that it's an AI library that helps developers create a large scale neural networks with many layers, including data flow graphs, facilitates building of deep learning models, and push the state of the art in machine learning and AI. And now the thing that kind of limits our capability to do this is to have the type of large scale, both networks, server farms, database clusters in order to even try something like this. So typically when you see companies using this technology, they're pretty huge corporations with huge resources and budgets. And you can see some of the people that use the technology. I mean, like, Google's using it, and Twitter, and Intel, and in fact, some of the training that we were getting from Intel Corporation talked about this particular technology. Very, very cool. And it's used for some really sophisticated things. So like once you get past simple data analysis and learn about mathematical modeling and linear programming, and neural networks and machine learning, those pieces, you can start to see some of this advanced stuff that this is capable of doing, like doing like real-time threat detection in gaming. Wow, that's pretty cool. And motion detection and face recognition. Those are all based on this technology, and I think it's pretty fascinating. A couple of others that they have here, Keras and the stats models. And this one here in particular, for those of you that are going into learning R, this is kind of has some correlation. So when you guys do get into the R programming language, which is usually a semester 3 class in our program, so typically a summer class, by the way, you use like a specialized language to do some things, but also to plot data. And this kind of borrows pretty heavily from that approach using some of the same types of technologies, and allows you to do some types of modeling that you can't do with other tools. Finally, there's this tool, Plotly, and this one's another one of those ones that is really popular because it does, once again, visualizations, but some of the cooler visualizations, I think, aside from like the basic types of charting, right, are some of these like higher end ones, so you can see like things that are like similar to the Seabourn styles are much more visual and sophisticated, the scientific ones, but then, things also such as, geographical mapping and the like, which is pretty powerful. And then this one always caught my eye too, and something I have not tried in the Jupyter Notebook yet, frankly, is that one integrates really nicely in the form of a widget. So it should natively work in the Jupyter Notebook is what that's basically telling us. Now, this is not a comprehensive list of libraries that are out there for doing data science. In fact, you will find that there's many, many, many more. And you know what? It probably is functionally impossible to learn all of them, but learning some of the basics ones are critical. And where we're going to kind of start out, if you kind of dig into the course shell here, is by working with pyplot. And that's going to be one of the first ones. And it's actually kind of a pretty satisfying one to work on, because once again, we're going to go back to our Python book. We're going back to chapter 3 on this, believe it or not. And what we'd like to do here is actually read that toolbox entry. And so what I'm going to do is I'm going to put that up on screen. Now, you'll notice that I did record a video last spring about this, so you can watch this kind of in the aftermath of class. You can see that during that class session, it took me 25 minutes to get through the topic and demonstrate it, and we do not have that kind of time here. So about the best I can really do is to get us started on this. But what I want to kind of remind you is this is from our Python book, and I don't know how many of you still have it. So whenever I pull in the exercises, here it is. If you don't have the book to refer back to, then you do have to watch the video to kind of get the content. So I'm going to make a note to myself when I teach Python again to data students, keep your book. Buy the book, don't rent it, because you'll probably want it for a reference. Once again, all the sample code from the book is here, which has the example files that are used to do the plotting. So let me see if I can get my book up on screen for starters. So I'm going to get that up first. And once you see the entry that I'm talking about, it will help. So I think the example is pretty nice and clear. And so what we're looking for is toolbox 3.2 in chapter 3. The way that they kind of organize this book, by the way, is they break it down into all these little sections. You're like, where the heck is toolbox 3? I don't see it. And that might happen to you if you have an ebook. But both, I think, the hard copy of the book and the electronic copy do give you quick links directly to these things right on the homepage. So I don't know what page physically this is in the book. It says 117 here on my ebook reader. If somebody out there has a physical book and can verify the page number for me, that would be helpful. And if not, hey, whatever. But let's take a look at what they're doing here. And I'm gonna I was just trying to make the font bigger, folks. And maybe I'll just use the more primitive technique of zooming in. All right. So that is not a font sizing tool. I'm assuming it's probably here, right? All right, anyhow. So they talk about what graphs are, and I think we kind of all get it, right? But then we look at a set of data. So they have this very simple little list of information. So they have the months of the year, and then the average temperature for Fairbanks, Alaska, during that month of the year. And then given that information, you can plot it, right? So all you need is basically, 2 pieces of information to plot stuff on an XY axis. And here's an example, and of the information actually plotted. And this is what pyplot will do for us. It will create this graphic, but using Python. And no, we don't have to create a GUI to put this into, but we could, right? So that's a possibility. In order to actually execute this, you just simply follow through the steps that they indicate here. And this is exactly why I use this as an example. I think they do a very nice job of it. And so you could just begin by copying the code, right? And you can see very, very quickly. In fact, I can probably just grab this and line by line and drop it in. But keep in mind that you can pull the code from the zip file, and maybe you already have this zip file. Okay, where's my file folder now? And I will extract it all here. And actually, this is really silly because I have the file already on my machine, but here we go, doing it again. Do you ever wonder why your downloads folder is so full of junk? All right, so you can come in here, go to chapter 3, find toolbox number 2, and then here is the information. Now, the little examples that they're using here, let's pull up the Fairbanks one. And actually what I did is I launched it. That's not what I wanted to do. I'm going to just open this here in
Where was that zip folder?
That is attached right here to the activity and readings and reference materials, Anthony. See that?
In 10. Okay.
Yeah, in unit 10. Yeah, it's unit 10. All right, so I have this this example here, and just to save time, instead of typing it all in manually, which is what I do in the video, I explain it and I type it all in and tell you what I'm doing. So if you want that kind of explanation, there you go. I'm going to just stick with our Jupyter notebook here. In fact, really, I should create a new, not a new cell, but a new notebook, and call this unit 10, example of pyplot. Okay, and I'm going to take this code and paste it in, and we'll look at it really quick in a couple of minutes that we have left. So to begin with, we do need to pull in one aspect of pyplot, and that is the matplot library from pyplot. So if this is just from this one library, what else can this library do? Well, that's where those standard library documents come in. You can go and read up on it. You can figure out what is it you want to do, how does it work? Then I'll try it out in my program. So we begin by just setting a bunch of variables. So we begin taking information. So January, all the months are listed, and then we just feed in floating point numbers into each one of those variables. So it has a name and it has a value. Then here, and this is a very primitive example, mind you, that the pyplot is done directly. So in other words, we're telling it, hey, we're putting this in a bar chart. This is the piece of information, and this is basically the first bar, right? And we go through each month and we plot it. And what is it plotting? It's plotting the number, right? So it's not plotting the month, it's actually plotting the value, and it kind of automatically looks at kind of the scale of things and plots it accordingly. The other thing that we do here, this little command, the plot thing, plots basically a horizontal line. So we have a horizontal line at 32 degrees Fahrenheit, so you can see when it's above freezing or not, and it's done with a dashed line. Of course, we can title it, put a label for the x-axis, a label for the y-axis, and then the more interesting one here are the hard-coded pieces of information that we're using to point out all the little spots on the chart. And without much time left here, folks, I want to run this. This is basically a two-dimensional list, right? If you guys remember what a list structure is, or a two-dimensional array, which means two lists of data that are interrelated, where here's the data, and here's the label. Now, I want you to keep in mind here that these are the marks on the chart. So this is what is at the bottom of the chart. So if you remember what the book looked like, wherever that was, right? So the X ticks at the bottom. So notice January, February, March, blah, 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 blah. They're all listed there relative to their position. And you know what, ultimately, to get it on the screen, you do the show command after everything's been built, and it should run. So I'm going to go ahead and run this inside here. I've never run pyplot instead of Jupyter Notebook before, but you can notice that not only did it do it, it did it pretty nicely, pretty quickly, and seemingly pretty accurately. And you see the line for the freezing mark and all that, and it automatically color coded everything with different colors. You can control that aspect of it too, just a matter of issuing the right command. But this is an example of pyplot in a very primitive fashion. Now, once again, we're working with a very small data set, very limited, but you get the picture here, folks, that we have these Python libraries that once we know how to work them, it's just a matter of learning the syntax. You can trigger things to happen and create things with it. Now, you might say to me, like, why, Ty, why would I do this in Python when I can just drop it in Excel and do it in like 30 seconds flat? Okay, case in point, right? Here you're learning, right? But if you do come up with more complicated data that is more difficult to plot in Excel, or you need to have more, granular control, I think the one thing that you guys might agree on is, as we were getting into some of the more sophisticated tools of Excel, sometimes we would kind of get lost in the muck trying to figure out, okay, where's that thing? I forgot where that thing is. Where am I going to find it, right? Where the advantage of working with code is it's right all here on the screen, and you're controlling it on a granular level. And, frankly, sometimes that's significantly more powerful, especially with large data sets. Well, folks, that ends this little lecture portion. So the video ends here.